Hi, welcome to our pre-calculus. Today we have a short topic using trigonometry to find the area of a right triangle. So let's remember the basic formula we know from probably middle school, that if you have a right triangle and the two legs are A and B, then the area is AB divided by 2. Well, what if instead you have one side and one of the angles? So suppose this is theta. Then this will be opposite of theta. And I can say that tangent of theta will be ratio of the opposite divided by the adjacent. So the opposite is A times tangent of theta. So the area then becomes A times the opposite, which is A tangent of theta, divided by 2, and that makes it A squared tangent of theta divided by 2. Similarly, if we had the angle opposite of this side was given to us, if this were the theta, this would have been the adjacent. And now we have that tangent of theta is A divided by the adjacent. So adjacent becomes A divided by tangent of theta. And then the area becomes the product of A and adjacent, which is going to be A squared divided by tangent of theta. And then I have to divide by 2. There's also a case where hypotenuse might be given. The questions in this section somehow don't include that, but let me just mention it for completeness. So if I have hypotenuse given to me as C, and this one of the angles is theta, then the opposite divided by hypotenuse is going to be sine of theta. So this side becomes C sine of theta. Adjacent divided by hypotenuse will be cosine of theta. Therefore, this is going to be C times cosine of theta. In this case, the area, the product of the two legs, is going to be C squared times sine of theta cosine of theta divided by 2. So that would be a third possibility in case you come across it. Let's go ahead and apply this idea. So in this problem, this is 19. Let me call this side x. So what would be x divided by 19? So that would be tangent of 35. Is that right? Tangent is the ratio of opposite to adjacent. So therefore, x is 19 tangent of 35. Then area is going to be this leg times this leg. So 19 times another 19 becomes 19 squared times tangent of 35, and then divide by 2 because, well, we have to multiply the two legs and divide by 2 to get the area, and then that's it. You enter that on your calculator and get the answer rounded to the nearest tenth, and then you'll be all set. In this case, let's call this one x. So tangent of 28 will be 11 divided by x. So x becomes 11 divided by tangent of 28. So this is 11 divided by tangent of 28. area becomes the product of these two. 11 times this 11, 11 times this 11, 11 squared, divided by tangent of 28. I have to multiply these two and divide by 2. So I have to divide by 2. Again, we enter this on the calculator and then we'll be all set. Let me just make up a problem of the third type. Suppose we have a right triangle. This side of it is say 17, and say this angle is 52 degrees. Let's call this to x and y. What can I write about x? Well, I connect it to 52 and 17. So I'll say cosine of 52. Cosine is ratio adjacent to hypotenuse, so x over 17. If I wanted to write sine of 52, would have been opposite, divided by 17. So this gives x is equal to 17 cosine of 52, and this gives me y is equal to 17 sine of 52. So what is the area? I have to multiply these two, 17 times 17, cosine of 52 once, sine of 52 a second time, and then divide by 2. If you want to apply some trig identities, I might remind you that we had sine of 2 theta was 2 sine of theta cosine of theta. So if you see sine of theta cosine of theta, you can replace it by sine of 2 theta divided by 2. In this case, we can replace cosine 52 sine 52 by sine of double of that angle. So I can write it 17 squared times sine of twice 52. Then I have to divide by 2, and there's a 2 here as well, and that becomes that quantity. So to paraphrase this, if I have C, and this is angle theta, area, I can write it C squared sine of theta cosine of theta divided by 2, or another form of it, C squared sine of 2 theta and then divide by 4. Okay, so simple exercise using identities and definition of tangent to find the area of a triangle in a special case. Until next time, good luck and God bless.